So the workbench is here, and Dad brought something else interesting today to show us. And it's very strange looking. It looks like something that you'd find in like a fallout shelter or like a ghost detector or I don't know what. Can you tell me a little bit more about this? Let me grab the camera.
This is a field intensity meter. It's a like calibrated system.
For ghosts?
For ghosts, for AM radio.
For AM radio.
Yeah, this one's for AM. They make them for FM, but this one is for AM radio. It's got a built-in, in the lid, there's a built-in loop antenna that you would orient to it, and it's calibrated. So we taped up a miniature version of their certificate of calibration here. So you can see, if you tune into 1100, 1.0, so it's the same, 1200, you get 1600, 0.995. You got to calibrate that in if you want to be as accurate as possible. These can be used to submit as readings for the FCC of signal strength at different points around the antenna when you have a directionalized antenna system. More times it would be used to just prove that your signal's getting out, right? So you have an AM, it's basically an AM receiver with a bunch of complicated controls to get an accurate reading of the actual field strength at the site that you're at, the point.
And I saw somewhere on here there's a serial number. Yeah, 878. It sounds like
there's 878.
There's not a whole lot of these floating around.
There's probably over 900 of them. But this is an FIM 21, so they have a 19 too, I believe, but FIM 21, serial number 878.
But this thing, it looks really old. Is it still useful? I also noticed when I was looking, it has March 19, 2024. That's this year.
Yeah, that is our calibration date. So I just got this back, calibrated, and where's the light? And the light. So there's lights down here and light there, the lighted dial.
Wow.
Because you might want to take those readings at night for your night pattern. See?
So there's a reason for that. I noticed in their literature on the Potomac, whatever, FM 21, they advertise the night as a main feature of this thing. Or not the night, the light. Well,
these are meant to be used in an open space, not in a... I mean, you can use them here for different things, but if you're taking an accurate reading, you want to be out in open space. So that'll be me, the guy in the middle of the intersection that has no stoplight sign, the stoplights. So I can get a better reading. I'll move out there if I have to. And then you orient the antenna and you take the reading. There's a lot of calibration and stuff to do.
So it looks like it's on right now.
It is on.
It's on a frequency above 1300?
1320.
1320?
Yeah.
Can you show me, I have my spinny chair over here.
Yeah.
Can you stick it on here and
let's stick it on
demonstrate how this thing works?
Yes, and you can see, so the loop antenna has a null position and a tune position, as you rotate it. So,
and of course, this, like
right
you
now,
said,
we're nulled.
For anybody watching this, we're inside of a building with a metal roof and stuff. This is not where you do a field calibration.
This is not actually doing a field measurement.
But it still can relativly show.
Right, and it does show you what you're receiving in here. So as I rotate it, you can see signals. So you see the signal is getting stronger. And if I go to 90 degrees, signal goes, it's nulled. So this is a loop antenna. They always have a null.
So inside of here, there's an antenna, you're saying?
Yeah, inside of here, there's a loop antenna, and you have a loop antenna. And some people have AM radios that have those little loop plastic antennas they give you. And the critical thing is to arrange that to get the best signal for your...
like this one up here.
Yeah, it's probably got a loop antenna in it.
Can we tune it to, what is
1320?
1320. Let's see if this, let me turn this down.
Yeah.
1320.
Is that it?
So you're saying that if we point it that way, assuming the antenna is the same, it's a little better.
Thanks for listening.
It's actually not, the signal's good inside of everywhere here.
Well, everything in radio, what's it getting received? Well, this could have a ferrite core that's up and down.
Or call us at 1-833.
Less directional antenna.
Okay, that makes sense. But I have a loop antenna over here, and this one, I've been experimenting with SDR lately, and I wanted to receive some AM stations, so I actually got the RTL SDR V4. This is the latest version that just came out last year, and my computer's gone to sleep. And I have it set up, and one of the questions I had was like, how do I figure out how to tune this antenna or get a good signal? And I noticed this thing has a little, I guess, a capacitor, a variable
Yeah, it's probably a variable cap in there, that's what I would assume.
And when I plugged it in, I did notice that as I move this capacitor, it does change the peak here.
Yeah.
So it does make a difference.
Yep.
But it's kind of hard. It's kind of a little thing, and you see the little waviness in the field of of waterfall display.
Yeah, you're seeing the noise floor move around.
Yeah.
And again, you got to decide, peak the signal, or do you want a lower noise floor? So if I roll that noise up here and that signal doesn't get hotter, all I've done is make the noise floor higher. So roll it right onto there. Yeah, see, the peak signal goes up because you want to get the peak signal increase, but the noise stay down is what you want. You want to have a gap there that gets bigger. When this happens, if that gap doesn't get bigger, you definitely don't want it.
But you also, you made the point that the directionality of this antenna is very important, and there's a null. A null means like if you orient it a certain way, you're not going to get any signal.
Yeah.
So can you, like if you turn it the other way, are we losing CAMWX completely?
So you can see, is that the...
That's CAMWX, right in the middle.
Yeah, so you're seeing if I rotate it, right there we're nulling, and then we're peaking, right, depending on the...
So that's, and you can actually take this antenna, unplug it right there, and we can bring it over here, and you could test this antenna on this unit. I don't think that's what this unit is for.
Yeah, well, no, it actually is. There are people that have externally calibrated antennas, but they're external, and they'd be big loops and they're on a specific frequency. So if I had a station like CAMWX, and all I was worried about was CAMWX, I would get a loop antenna that I could mount on a tripod or even a mast, so I could drive around and just throw the mast up in the air in a clearer space. And then I would have to be able to rotate it to get it tuned in. So you have an external antenna. So here, when I throw the external antenna on, so that's pretty low.
Not much signal.
Let's go down and get more gain in. There's not much signal at all.
Yeah.
But let's pick this up.
And maybe tune the antenna too.
See, look at that. So here you can see your antenna there. You're peaking the signal right there.
We get
right.
So do that again. Do the move
okay.
around.
So here, you peak the antenna, null. Null goes way down. Peak the antenna. Right?
Yep.
Null it.
And then if you tune the knob, does that make a difference too?
Yeah, that should make a difference too. So let me tune it where I got the knob on this side. So you go here, kind of peak it. Oh, now we can go up a scale. Go up another scale. Oh, a huge amount of gain there, right?
Yeah, so that
we went from down to microvolts.
I just remember as a kid, I would always be fiddling with antennas, and it seemed to never make a difference unless you held the antenna. But this looks like it could be nice to actually calibrate it a little bit.
Yep. Well, you can see that made the difference. We're now at 6 millivolts, and we were at so many microvolts. We were at probably 50 microvolts, and we went up to, what is it, 5? Oh, that's 3.5 millivolts. So that's a pretty decent gain just by tuning this knob right here. And
this is for AM, but there's a lot of different radio frequencies. Is it a similar kind of principle for FM?
FM's antennas are more non-directional, but from the receiver point of view, you do always want to be aimed. If you have an antenna, like if you have just a wire, it's not going to make any difference. You can't aim it. But if you have an FM antenna, it's going to be more, it's going to have its poles out like this, and you're going to want to aim that. But on FM, you can also pick up bounces, just telling people who live near big cities and stuff. You can pick up some pretty awesome bounces and get good reception without pointing straight at the tower. And in fact, you could get reflections off buildings equally strong and almost cancel the signal. So you do want to aim the FM antenna, but it's going to be 2 poles, and you're going to be aiming it, with the poles like this. You're going to be aiming it, like that. At the loop antenna, you're going to rotate a loop around and aim it at the tower site. So anyway, that's the gearling tip of the week.
Well, getting back to this guy, is this your box, or is this owned by a radio station?
Yeah, this is the Covenant Network box. It's the box owned by my radio company I'm working for now. Typically, a lot of consultant engineers buy these, and they were several $1,000s new, and now they're a couple of grand. You could probably pick one of these up, I'm guessing. But they're very useful if you go around and want to know accurately, what is this signal? Supposedly, I would be getting the same reading that the guy did 25, 35, 50 years ago. And most of the AM stations, somewhere there's documentation. The guy said, I'm at the corner of this road and that road, Mills Holler and Hard Rock Road or something, and they would have the exact point marked because they would want to go to the same spot every time they took a measurement.
And do you have to do that like every year, every 10 years?
It's different for different stations. Pretty complicated to say, but yes, you will want them regardless at some intervals to know that your signal is getting out. You could take one in a null to know how good your null is working, and you'd want one in your peak direction. But you could take it within a few miles of the studio, or the station, the tower. You could take that and then you'd know it's like my peak looks about right for the peak and the null looks about right.
And you're saying for like AM directional things like those crazy towers,
yes.
with 5 towers that
yes,
you saw
the ones that have all the loops and stuff. So you want to know because it'll tell you that's the performance of your grounding system, the performance of your antenna, tuning, and all that kind of stuff comes into play.
So when you go out in the field, we're inside right now, so again, this is not a highly calibrated, perfect reading, but like what would you do with this?
Well, you would take, first of all, you got to choose your frequency. So this is not a great way if you're going to do 10 stations in one spot, because each time you got to tune to that frequency. So if, like, say I'm going to take this... But you
want to switch off my antenna, probably.
Yeah, so we'll do that just for demonstration purposes. Yeah.
Super antenna built into it that's calibrated.
So the first thing you do is you're going to tune in your station. So we'll pick... let's go to
KMOX, maybe?
Yeah, we'll go to KMOX.
The mighty
Might
signal.
be able to receive them down here. Okay, and you're going to tune them in.
Total Information AM. Information to start your
I think that proves it.
St. Louis's News Radio.
Okay.
KMOX.
So you tune them in, and then the next thing you're going to do is, now you've got them tuned in, you're going to do your calibration. So you're going to put it to the calibrate position, and you're going to calibrate the tune. So you're going to go to the calibration oscillator, and you're looking for a peak. So you get a peak. That came up pretty quick and pretty solid. So I'll use that for the peak, and then I'm going to calibrate for the null, in which I'm going to use the gain here. And now I'm looking for a null. I don't know if you can hear anything on the null. But anyway, so I'm going to tune for a null. That makes this accuracy of 1 at this frequency. This now is a calibrated accurate at 1120 for the measurements. And then I can take my measurements, go back to field intensity, go back off of calibration here, go down until I get, so I'm on the 10 millivolt scale. So that's going to be 10 millivolts. So it's going to be 8, a little over 8 millivolts, 8.5 millivolts. So that would be the reading I would log down, is 8.5 millivolts right here at this setting, with my hand on the antenna, on a chair in a building with walls and steel.
So if you were doing like a field reading, you'd actually have more of a reproducible setup, not just setting it on a rolling chair.
Right, yeah, exactly. Probably you're going to have a tripod, and this thing does have, at the bottom you can see the threads for a tripod. See that?
Yep.
And so you could put this on a tripod, collapse the tripod, throw it in the back of the vehicle, drive to the next spot, open it up, just touch up your calibration because you're doing the same frequency. Take your reading, and of course, in the readings you take out there, you want to be in open spaces as best you can, and you want to be away from the meter as best you can. You don't want to be sitting there like this doing the thing, but you're going to try to have a little effect on the antenna as possible. And so some guys use external antennas so they can operate the equipment and the antenna is away from them a little bit and get their readings.
AM radio is not what it once was in terms of popularity and all that, new stations coming up and all that. Are these still in high demand? Or I think I even saw an EEV blog on the forum, somebody had posted one for sale and it was months later and they're like, I still have it.
Yeah. These are not going to be in too high a demand. And the other thing is they do have other equipment and other ways of checking. If you're just looking for, am I nulled or am I peaked, you could do that without a big expensive piece of gear, So people have ways of getting enough information to feel comfortable in between having to have a report. Like if I changed a tower, if I moved a site, you have to have a bunch of reports. There's just other ways to do things in the professional radio industry. And then there's the dream, Jeff, of the glasses that do what this does, only you just put on glasses and you just tune and you can see the RF directions, it gets brighter. That would be fun. Well, hasn't been invented
I think
yet.
It's interesting too. Like I think one of the big reasons for this still to be around, like the reason you guys still have one, is it's calibrated.
Yes.
So there's like a
yes.
proof that it goes back to the company.
Yes. Goes back
they
to,
have a guy who signed it, and it's
right.
like this is actually can be used for the FCC. Just like that oscilloscope up there on the shelf.
Yep.
That one is not a calibrated one, therefore it's like half the value.
Yeah, right, exactly. The calibrate, you can get paid if you have calibrated. You know, and this one says here, it says, like a lot of them, it says calibration maintained equal to the National Institute of Standards and Technology standard field within an accuracy of 1%. So you get that kind of ability. That allows you to submit reports that have become official, right? For the, it's like the guys going around, there's radiation in the creeks, there's radiation here, which we have actually experienced in our life here, or I have anyway. And you got to trust their equipment. Otherwise, they're going to be, you know, who knows what, especially scaring people, right? You don't want to do that.
But if you wanted to scare people, you could take one of these to a party and have it strapped around your waist or something.
Exactly.
And say like, oh,
pointed
there's
at
a ghost.
people. Yes, that would be funny. So anyway, great also by the pool. You know, you could have it tune in the car baseball.
Yeah, you can turn it up a little bit and
put it by the
listen to
pool
some
and
tunes.
nobody knock it in.
It's probably the most expensive AM radio that I've seen.
Yeah, it is. I'm sure it is.
How much does a calibration cost?
That's called catch you back over $1,000. So you know, when you get it calibrated, you want to know that you're going to use it. And I just happen to have about 3 important uses for this. So it's a lot about proving out my ground systems are okay, because I got in stations I'm not familiar with, the ground systems are 30 years old or more, and you just wonder, like, is the signal getting in the direction we think it should at the level it should?
So big question. Do you think this has enough accuracy that if we went back out and did another hot dog tower experiment, would we see any difference when we touch the hot dog to the tower?
I think we would. It definitely has the ability to detect that. How much energy was drawn from the hot dog? That is the next question. A lot of you are curious, admitted. So it's like, how much energy is going on? Why is that color that color? Could we make it a different color? Send us your favorite color and we'll try that.
Yeah, let us know what things you'd like us to touch to a radio tower.
Yeah, we'll see what happens.
All right.